Hello, 171 class. This is your notes for section 7.1 continued. This is part, I think, 4 now. We are doing some word problems, so some application of systems. So we have a chemist working on a flu vaccine. He has to have a 10% mixing a 10% sodium iodine solution with a 60% sodium iodine solution, and he wants 50 milliliters of a 30% solution. So a little bit stronger than this, about half as strong as this. Okay, so how much of this 10% solution does he need to add to 60 to be mixed? So here's a visual. We've got our mixture we're going to put here. We're going to take, this is our 10% solution, this is our 60% solution. We're going to pour them together in here, and we want a 30% solution. Okay, so we're going to, if you see it, 10 is closer to 30 than 60 is. We're going to need a little bit more of the 10% than we are the 30. But anyway, a way to do this is to set up a system of equations. And one thing that we're going to use, one equation that we're going to use is the number of milliliters. So I want 50 milliliters of this solution. And the other equation is going to be the sodium iodine equation. Alright, so the way I think about these is the milliliters, think of that as the numbers that are on the actual beaker, or whatever you want to call these. So the amount that of milliliters that have to come from this 10% solution, I'm going to call that X. So X milliliters have to come from this 10% solution. And then the amount of milliliters that have to come from the 60% solution, I'm going to call that Y. Okay, that's the number that have to come from the 60% solution. Now, this X and Y may not be, at the very top. Okay, I'm not necessarily saying that's the way it is. I'm just saying somewhere on here is the number of milliliters that have to come from this percent solution. Somewhere on here is the number of milliliters that have to come from this 60% solution. Okay. And then what's going to happen is I'm going to pour this X amount into here, and I'm going to pour this Y amount into here, and together these two things are going to come together and perform a mixture. And that mixture, it says, needs to be 50 milliliters. Alright, so don't look at the numbers on the cup. Alright. So what we know so far is X plus Y, when I add these two things together, when I combine them together, that amount and that amount that are coming from each of these things has to add up to 50 milliliters. So the milliliter equation is just X plus Y is equal to 50. Alright, now the other part, the percentages. So what this means, 10% of this left-hand side, 10% of all the blue stuff in here is sodium iodine. So not all of it, just 10% of it. So like for instance, if it's settled to the bottom, like if we just set it there and the mixture kind of separated, and the sodium iodine for whatever reason was the heaviest and it settled to the bottom. This is just for instance, that's a 40. 10% of that would be 4, which would be way down here. So if it all settled to the bottom, this part right down here, the bottom 10% would just be sodium iodine before I mixed it back up together. So if it settled to the bottom, like the bottom 10% is sodium iodine. Well, that's 10% of whatever the amount is, of the X amount is what's going to go into here. So whatever X is, 10% of X goes into here to become sodium iodine in here. So this is 10% of X, I'm going to write that as a decimal, is 0.1 times X, is what percent of the X value that's coming from this beaker that's going to go into the mixture. And then likewise over here, it's 60% of this mixture over here is sodium iodine. So like 60% would be a little bit more than half. So like if it's settled again, if it broke apart and settled, then the bottom 60% of this jar would be the sodium iodine. So this amount right here is 0.60 or 0.6 times whatever y is, and that's what's going to go into here. And those two things together, those two amounts together, are going to end up being 30% of the overall 50% of the milliliters here. So 30% of this, about a little bit less than a third, 30% of this mixture, these 50 milliliters, are going to come from the 10% here and the 60% here. So this piece right here is 30% of 50 milliliters. So that's multiplication, 0.3 times 50. So our sodium iodine equation is 10% of whatever X is plus 60% of whatever Y is, comes together and becomes 30% of the 50. All right, and then we can just go ahead and multiply that out. 30% of 50 is 15, right? So instead of writing 0.3 times 50 here, I'll just write that as 15. And there's our system of equations. All right, so x plus y equals 50, 0.1x plus 0.6y equals 15. Now, this is a word problem, an application problem, applied problem. So for me, it's perfectly fine. You're being tested if you can set up a system here, not your ability to solve. That's what you were tested upon on a lot of the other questions from the previous examples that are going to look, like this. All right. That's the stuff you're going to be asked to show your work on. A question like this, you're being asked to show me that you can set up a system that will solve this. So it's fine with me if you go straight to your calculator and put this in. Second matrix, I'm going to go over to edit. So 2 by 3 again, because we have two equations, two variables plus a constant. That's where the 3 is coming from. So plugging in my numbers, I got a 1, and a 50. And then for the next one, I have a 0.1, 0.6, and a 15. All right, so there is my system. I'm going to back out, and remember, go back in, go over to math, RREF, and then call matrix A, whichever one you've set up. So there's what we need. Remember, this is x plus 0y equals 30, so x equals 30. Y, 0x plus 1y equals 20, so y equals 20. Now, the other thing you have to be able to do and understand here is what is x and what is y. Well, I'm multiplying x times 0.1, so that's the 10% solution. So I want 30 milliliters, the 10% solution. I want 20 milliliters of the 60% solution. Okay, so we declared x to be what came from the 10% from this drawing. We declared y to be what came from the 60% from this drawing. So when we got x and y, we need to also know which one's which, because if you flip it around, it's not right anymore. So just make sure that you have the labels correct, what these numbers actually are once you solve for them. All right, let's look at a similar problem, but a different type of application. Small airplane is flying with the wind. It can travel 450 miles in 3 hours. That same airplane flies in the opposite direction. This same 450 miles, it takes 5 hours. And so what we're being asked to do is find the plane speed, right, and the wind speed. So we're being asked to find these two things. Now what you have to remember with these types of problems, as soon as you start seeing distance units, time units, velocity or velocity units, speed units like miles per hour, feet per second, you need to immediately think distance equals rate times time. So what we're going to do, again, remember, we're in systems of equations. We're going to make an equation for the speed of the plane with the wind and one against the wind. But in both cases, the distance equals rate times time is going to be the form of both of these two equations. So let's do the top one, the width. So we've got distance equals rate times time. We know the distance in both cases is 450 miles. So distance equals rate. The rate depends on whether we're going with the wind or against the wind. When we're going with the wind, this plane is flying in the direction of the wind. So these two things are being added together to combine for the plane speed, the rate. So if we call the plane speed x and we call the wind speed y, the two are combining together. Like if this is 200 and this is 10, that plane is in essence flying 200 plus 10, 210 miles per hour. So we add the two speeds together to get the rate. So 450 equals x plus y times time, right? Well, it says right here it can go this in 3 hours, right, with the wind. So with the wind, 3 hours. So times time, okay? Distance equals rate times time. And then we do the same thing for the other one. Distance is 450 miles, so distance equals rate. But now this time the plane speed and the wind speed are offsetting one another. They're going in opposite directions. So again, the plane speed, we're considering that x. The wind speed, we're considering that y. But because this is going in opposite direction of this, we subtract to get the rate. So if this, again, this is 200 and this is 10, like we said before, 200 minus 10 is, in essence, this plane is going at 190 miles per hour. So x minus y is the rate. Okay, now the plane speed is going to be higher than the wind speed if this thing is actually going to, cover the 450 miles. So make sure you put the x in front of the y in the back, or you'll get negative numbers for your solutions. Okay, and then, or you'll actually just have these inverted. Your plane speed and your wind speed won't be negative. They'll just be, you'll find your plane speed will be your wind speed will be your plane speed. All right, and then how long does it take to go back the other way? It takes 5 hours. Okay, so this is the system. This is a setup, but to make it something that I can put into my calculator, I'm just going to distribute the 3 and the 5 through. And then I'm going to flip the order around to put the x's and the y's first. So if I distributed through, I'd have a 3x, a 3y, and a 450. Okay, I'm just distributing on the one side of the equation. And then a 5x minus 5y equals 450. All right, and now I'm ready to go to the calculator. So last thing I did was REFA. Keep that in mind. Go into the matrix, edit this 2 by 3. So 3, 3, 450, 5, negative 5, 450. And remember, because the last thing I did was REF, I can just hit enter, and there's the two numbers. So that's telling me x equals 120, y equals 30. And remember, x is the plane speed, and that's 120 miles per hour. Y is the wind speed, and that's also miles per hour. So a quick visual, it doesn't hurt to sketch a picture, but it also, we're in this section where we're doing systems of equations, so you're also going to set up some systems to be able to solve these problems. All right, one last type of application that you'll see in your homework, revenue, cost, and profit functions. So a revenue function, revenue is how much money a company takes in when it produces and sells goods. So the revenue function is the price that you're going to sell your value for, your goods for, times how many you sold. So if you're selling them for $5 each, and you sell 100 of them, 5 times 100 is $500. Okay, that's your revenue. But cost is your fixed cost, like your operating cost, your rent for the facility, times plus the cost for each of these individual units you make, times how many you make. So the first thing we're being told to do is come up with the cost function in this scenario. So it's planning to manufacture these different wheelchairs. Fixed cost is 500 grand, so the cost function C of X is the 500,000, and then we add the marginal cost, which is $400 to produce each wheelchair, so 400 times X. Alright, and then the revenue function, R, it's the price that we're going to sell them for times X. So the price we're going to sell them for is 600, so that's just 600 times X. Alright, break-even point. Describe what this means. Break-even point is where cost equals revenue. So we set these two equations equal. We set cost equal to revenue, and we solve for X. That'll give us how many we need to sell. And then when we plug in that X into either one of these, it'll be the same because they're equal. Easiest to set it into this one. And that'll give us the cost and the revenue earned for producing that many items. Alright, the break-even point happens when cost equals revenue. So here's the cost function, here's revenue function. We're just going to solve this equation for X, and that's how many items are needed to be produced for cost to equal revenue. Alright, so we're going to divide both sides by 200. That's going to get rid of 2 zeros up there, and then we got 5,000 divided by 2, so 2,500 is how many goods we need to produce. Alright, and then if we plug in again that 2,500 into either the revenue or the cost function, I'm going to plug it into revenue, we get the amount that it costs to produce that many, which is also the amount of revenue at that if we sell that many. Okay, so 2,500 times 600 is 1,500,000. So that's our revenue and our cost when we produce that many goods. Just to show you, I plugged it into the revenue function. I multiplied by 600. But just to show you, if I take 500,000 and I add 400 times that same number right there for X, 2,500, I get the same number. So they are the exact same. Revenue equals cost when we produce this many goods. Alright, now describe what it means. What does it mean when we found the break-even point? Well, in this case, it means because the slope is higher for the revenue function. If we go beyond that number, that 2,500 number, the more we produce beyond that, because the revenue had a bigger slope and a steeper slope, now we have a gain. Our profit is positive. We're earning more. The revenue is higher than the cost function, so we have a gain. But if we don't produce that many, we have a loss. Right? If we don't produce and sell that many, this 500,000 like startup cost, this fixed cost, is not offset, and we have a net loss after all is said and done. So the profit function is always going to be revenue minus cost, and if you look in your work, you always have the profit function in there. So revenue, if I subtract the cost, it's just the opposite right here at this step. If I go this way instead of subtracting this way, I end up with revenue minus cost. So the profit function is the 600x minus 500 grand plus the 400x. And because I have to distribute this through, it's the 600x minus, I'm going to go ahead and switch the order, minus 400x minus the 500,000. I'm switching around because I'm going to subtract these. So we end up with 200x minus 500,000. Well, what does this mean in this case? Well, it means our profit per item is $200. $200 per item produces our profit, okay, because we're selling them for $200 more than we're cost us to produce them. But then we have this fixed cost to overcome before we actually produce a profit. So that negative 500 is staring us in the face until this number for x gets big enough to offset it. And again, there's the number that we need to get to offset this thing. So the profit function, we always take revenue, subtract cost, and distribute, simplify, and that'll give you your profit